Welcome everyone to another Kuta worksheet tutorial. Today we're doing multiplying polynomials. Let's go ahead and get started. The question is find each product. What we're doing here is we're just multiplying. Notice that there's no equal signs. We're not solving for x. We're just essentially distributing. Now what you really need to understand is you need to understand powers before getting to this section. Like what you need to know is if you multiply a power of like bases, you add the exponents. You also got to understand that you can't combine powers of, same base here. You see v and v, but they do not have the same power, so you cannot combine these. That's something you got to understand. So with that understanding, let's go ahead and apply it. If you have inside the parentheses first, there's nothing to combine there, but you look outside and we see that we can distribute. You multiply the 6v times the 2v and the 3. What you want to do here is we have, let's change this to green. We have the 6 and the 2. That you multiply the coefficients and you get 12. And then you have the bases. We have v and v. So the bases are going to stay the same as v, but then we essentially add the exponent. There's an implied 1 for both of these. So 1 plus 1 is 2. V times v is v squared. V times itself twice. That's essentially what we're doing. Here we have the same situation with the coefficients, so to speak. It doesn't look like there's a variable. Technically, this could be written as v to the 0 power or just 3, if you're thinking about that. But this is usually referred to as a constant. But we just multiply 6 times 3, we get 18, but you cannot forget positive 18. But you cannot forget the v that is with the 6, so we leave it as 18v, and that's our final answer. Simply that. Okay, so let's move on to number 2, and then we'll kind of go a little bit faster so we can get to some tougher ones. Again, we're distributing here because there's nothing we can do inside the parentheses. This time it's just a constant outside, so we're going to multiply just the numbers out in front, and we're going to leave any variables attached. So we get 7 times negative 5 gives us, let me change to green, negative 35. We're going to leave the v attached there. And then we have 7 times negative 8 gives us negative 56. And that's it. That's our answer. So this one was a little bit more simple. Okay, let's go to maybe some more difficult ones. Okay, you can see that we have two binomials. It's funny how it says multiplying. This is multiplying polynomials. Great. So we have here binomial. What does that mean? Well, binomial means two terms. So we have 1, 2 here, 1, 2 here in each set of parentheses. Now, like before, what we did is we multiplied. Just imagine that here. I'm going to white it out so you can see what I'm talking about. So imagine that this is gone. Okay, if we just had the 2, we would distribute just like before. Okay. So we do 2 times 6n. Let me go ahead and show this in pink or magenta, whatever you want to call it. We get, whoa, need to thin that up a little bit. So we'd get 12n and then plus 2. Okay. Now imagine, okay, let's do this. Now imagine that we have this disappeared. Okay. How would we multiply 2n times 6n plus 1? Well, we would distribute again. Okay, we've been using green, might as well continue that pattern, like this. We would multiply 2n times 12n would give us, sorry, did I say 2n times 6n gives us 12n squared, because we have n times n now, and then we would have plus 2n. Whenever you multiply binomials, 99.9% of the time, you're going to have a necessity to combine like terms. So we have like terms right here. Now, there's going to be some terms that you can't combine. For example, the 12n squared and the 2 you can't combine. But we can combine the 12n and the 2n. So we're going to write it in descending order. So the biggest power first, standard form, followed by the next highest. So in this case, it would be the n's. So we get 12n plus 2n gives us 14n, and then plus 2 at the end. And that's going to be our final answer. So that's essentially how you multiply two binomials. A lot of people will talk about FOIL, how you do first, outside, inside, last. And that's all great and everything. I don't have a problem with that, so to speak. But I really prefer just drawing, showing two distributions. And essentially the idea here is to connect both terms inside one parenthesis, draw arrows to both terms in the other set of parentheses. So this 2 needs arrows to both the 6n and the 1, and this 2n needs arrows to the 6n and the 1. And once you do that and show that multiplication, you're covered. You've done FOIL, okay? So you're done with that, and you've done every necessary step. That's how I prefer to do it. I'll have another video on this too to show that process, but I think it's much quicker this way. All right, so let's go ahead and get to some tougher examples. Okay, let's start with 11, I guess. So I'm going to do this a little bit more quickly now that we got the hang of it. We have 2a times 8a, that gives us 16a squared. And then 2a times negative 5 gives us negative 10a. Then I like to change colors. I'm changing to purple now. Minus 8a and then plus 5, because negative times negative gives us positive. We're going to combine like terms in green. 16a squared minus 18a plus 5. And that's our final answer. All right, let's move on to, okay, if it's something like this, I think the easiest thing for most students is just to rewrite it like this. So if you see a squared, it essentially just means times itself twice. So you write it twice next to each other, and then you show the same process. So you draw 2 arrows there, you draw 2 arrows there. I like to do above and below just so it helps me out. I always do the upper one first, so that's 16p squared minus 4p, and then below, minus 4p plus 1, and I get 16p squared minus 8p plus 1. And that's it. That's my answer. Now there's special rules with remembering if it's squared, you square the first time, double the sum of the two outs. There's a big process, and if you recognize that pattern, you can do it. That's great, but my experience has been that just overcomplicates things for my students, and it's just better to write it out like that. Let's go down to, okay, this is one I wanted to get to. So hopefully you guys have lasted this far. What happens when we have this situation here? Well, it's almost exactly the same as we did before. So what I'm going to do is I'm going to draw arrows from 4a to the terms in the second set of parentheses. The only difference is now I have a third arrow. So I have to do 3 series of multiplications. So I have 4a times 6a squared, that gives me 24a cubed. Then I have 4a times negative a, that gives me negative 4a squared. Then I have 4a times 2. This is the one that I did the dotted line with. I'm going to make it solid because I really don't like it. And we get positive 8a. And that is that first step. Let me move this down because I want to go beneath. Let's go blue this time. So now we have to do the same thing with the 2. We want to match up the 2 and multiply it with every term in the second parentheses also. So we get positive 12a squared minus 2a plus 4. Okay, and that's what those are the 3 multiplications that I just did. Now we're going to be looking for like terms, and we have to be careful here because there's going to be a little bit more to keep track of. So we have 4a squared, negative 4a squared, positive 12a squared. Then we have, let's go this green color, 8a and negative 2a. Okay, so we just have to be careful as we combine these terms. Usually the largest and the smallest just get left alone. So we're going to have 24a cubed, he's fine. Then we have negative 4a and positive 12a squared. We get positive 8a squared. 8a minus 2a, positive 6a, and then we have plus 4 at the end, and that's it. We're done. That's all there was to it. So it's not that much more difficult, just a little bit more intensive, one more step to remember, and that's it. We'll do one more quickly, and then I want to show you this guy that scares a lot of students, but again, it's just a matter of staying organized. So we distribute, this time it's trying to trick us, so I'm going to go kind of backwards here, okay, like this. And then I'm going to show this multiplication like this. So just make sure, I like going from the smaller one to the bigger one, but as long as you match up everything, it's really not a big deal, no matter how you do it, how you pair it up. So I'm going to do purple first. I get -4, I get -8n plus 12n squared, and then plus 2n cubed. It's a little awkward just because I'm going in kind of reverse order here, but it works. Plus 16, -4, negative, becomes positive, -24n, and then -4n squared. I'm going to combine like terms here. So let's go dark blue. I have 8n, and then a -24n, and then I have positive n squared and a -4n squared. So I'm going to start with my biggest power right there. My next biggest is n squared, and it's going to be positive 8n squared. Then I have -8n and -24n. That gives me -32n. And then I have plus 16, and I am done. Okay, last one. Yeah, this one's fine to end on. 23 and 24 are the same. What happens here? Well, we have two parentheses, each with 3 terms, trinomials. So what I need to do is 3 different times I need to match up this first term with all 3. And usually I would just, I don't have anywhere else to go. I went underneath, okay, to all 3. And then I need to find a way to get this guy. I don't know how to do this, honestly. And then I need to get him, the last term, to all 3. So it's 3 parts here. Definitely need to take my time, stay organized, so I'm going to really use as much space as possible. I have 6n squared. This I'm doing purple, or no, sorry, magenta first. So this is my first step. I don't know how to do it. I'll just say make a star, I guess. So I have 42n to the 4th plus my second arrow, 36n cubed, third arrow, minus 30n squared. Okay, so I'm done with the magenta. Now I'm on to the green. That's next. So now I have negative 42, that's not 2, 42n cubed. Now I have it to the next one, minus 36n squared. And then last one, plus 30n. So again, this takes up a lot of space. Just take your time, be careful, and then stay organized. And last one, we have negative 35n squared, minus 30n, and then plus 25. This is the tough part. This is where I have to combine alike terms, and there's going to be a lot of them. Okay, so I'm going to use different colored, I'm going to just use different styled lines, because I think that'll be the easiest. So there's no other n fourths. He's going to come down, 42 n to the 4th. No other of those. I do have n cubes, and I have 2 of them. And I combine these, and I'm going to get, what's that, negative 6n cubed. So I'm done with that. I'm going to cross them off as I go just to stay organized. Now I'm on to n squares. I have a few more of those. I have an n squared here, an n squared here, and I have an n squared here. Oh boy. So I have 3 of them with a total of negative 101. I think that's correct. 101 n squared. 36, 66, and then 35. That takes me to 101. Okay. So I'm done with the n squareds now. Now I'm on to n's. Okay, going in descending order with my variables, just in case you're wondering. So I go 4, 3, 2. Now I'm into the first power, and I have positive 30n, minus 30n. That actually just cancels out, becomes 0. I wouldn't write that. I would just leave it off. It gets reduced to nothing. And then plus 25. The 25 doesn't have any friends. He is by himself. And that's our final answer. That's how you do it. Hope you guys enjoyed this video. Hope you learned something. Hope you guys watch in the future. Make sure to check out some of my other videos if you're confused on any other concepts. And I hope to see you next time on Wes Explains Best.